As some of you may know, I have been experimenting with reconstituting freeze-dried breast milk, and it seems like no matter what I try, there's always a little bit of graininess in the texture that's left behind. And I can't get it, I've had a hard time trying to get it back to its original breast milk version, where it's really creamy and smooth and homogeneous. And I want to know why. Why is it that there's always that little bit of a grainy look to it, even after trying different things? And so I did a little bit of digging, and the things that I found are absolutely amazing. I hope you can stick with me because this is so cool. I drew a little diagram because I don't want to deal with copyright infringement issues. So mammary cells produce lipids, and when the lipids are excreted from the epithelial lining of the alveolar cell, it acquires a tri-layer phospholipid membrane. And this membrane is called the milk fat globule membrane. It's comprised of lipids, proteins, and enzymes that have both hydrophilic and hydrophobic properties. This is important because it acts as an emulsifier for the fat, meaning that it can blend into a watery solution. This is why milk is creamy and it doesn't separate, like the fatty particles don't separate out of it. It's because of this membrane that acts as the emulsifier for the fat. Isn't that amazing? That's so cool. But here's the thing, as soon as breast milk is expressed, the enzyme lipase starts to act on it immediately, breaking down the milk fat globule membrane and also breaking down the lipid inside the membrane into fatty acids and glycerol. This is called lipolysis, and it's important because breaking down the fatty acids actually makes it easier to digest for the baby. It also happens really quickly. There was one study where the milk was kept at 77 degrees Fahrenheit, and within 24 hours, the fatty acid concentration already increased by 5 to 6 times. That is really fast. So it doesn't take a whole lot of time for the lipase enzyme to start breaking down this membrane and breaking down the fatty acids. And I wonder if this is what we're seeing when we're reconstituting the freeze-dried breast milk, and we're seeing all those little grainy-looking bits along the outside that don't seem to dissolve very readily. I wonder if those are the fatty acids that have been broken down that are no longer soluble because they don't have the emulsifying membrane surrounding it, making it soluble. The next thing that I was curious about is once fatty acids are broken down, are they able to be re-emulsified somehow? And the answer is yes, sort of. If you blend fatty acids, it'll actually break it down to even smaller pieces, and that actually makes it blend a little bit better in the solution. And that's kind of what we found when we did the immersion blender test. Blending the solution seemed to make it dissolve a lot better, and it wasn't perfect, but it was the best that we were able to get it out of all of the experimenting that I had done. And so it seems like maybe that is breaking down the fatty acids and making it mix into the solution a lot better. Anyways, hopefully you found that as interesting as I did. If your milk looks a little bit funny or you're a little bit concerned about it because it's not mixing well, hopefully this gives you a little bit of peace of mind because there's nothing wrong with it. It just might be that the lipids are being broken down because of the enzymes in your breast milk, and there's nothing wrong with that. So I came across some really, really cool resources in looking into this, including pictures and videos and articles that I found really interesting. And it talks not just about the emulsifying properties of MFGM, milk fat globule membrane, but also a lot of the other benefits that it has in our bodies. There's even technology now that's taking the MFGM and putting it in infant formula so that infant formula can have some of the same benefits as human milk, which I just thought was so cool. So I'll list these resources somewhere in the description or in the comments so that you can look it up if you're interested in researching into it like I was.